In 1987, the Ferrari F40 became the first street-legal car to go 200 miles per hour. In 2005, Bugatti's Veyron hypercar broke the 250 mile per hour barrier. In late 2019, the Bugatti Chiron Supersport became the first production vehicle to ever reach 300 miles per hour. But why has it taken almost 15 years just to go 50 miles per hour faster?
You think about speed as a linear measurement, and I suppose it should be to a human brain. But if you've ever gone 150 miles an hour before anywhere, if you then step that up just to 180, it's only 20%, but the difference is huge.
That's Andy Wallace, the driver behind Bugatti's 300 mile per hour run.
Aerodynamically, downforce, lift drag, it's all increasing exponentially as a square of the speed. If, for example, you had a car that was capable of 270 miles an hour, the efficiency you need to take that same car up to 280 is pretty massive.
The power needed to overcome a force like drag or air resistance is most intimidating. The force required to push an object through the atmosphere increases at the cube of velocity. To translate, a car that needs 200 horsepower to overcome aerodynamic drag at 150 miles per hour would need 1600 horsepower, or 8 times as much, to reach 300 miles per hour. But to build a 300 mile per hour car, it's not as simple as a monstrous engine. First, you need to start with the tires. While they're not the most complex car part, as the only part that touches the road, tires are one of the most important. And at 300 miles per hour, when a puncture or blowout can end in disaster, they mean everything. At that kind of speed, the Bugatti's tires spinning 68 times per second had to withstand 7 tons of tearing force, trying to rip them apart. For an idea of just how intense that is, the tires on a Porsche 911 driving full speed only experience about 3.
One of the things you need to do is you need to stop the tyre from changing shape, because these enormous tearing forces would actually make the tyre quite crowned on the top. The tyres were not totally different, same carcass, same mould as the standard Chiron tyre, but what they did do is reinforce the very last steel band that goes on the tyre before the rubber goes on. I think the tricky part was they didn't want to increase the weight of the tyre.
To do this, Bugatti chose every engineer's favorite weight-saving material, carbon fiber. It can be 10 times stronger than steel, but 5 times as light. After adding a thick layer under the tire's carcass, the layer of rubber below the tread that's responsible for absorbing shock, Bugatti's engineers had to test it. To make sure the tire could handle 300 miles per hour, they brought it to Michelin's Aircraft Test Center in North Carolina. Using the same test bench used by companies like NASA, they found that it could handle up to 318 miles per hour before warping. But even the strongest tire means nothing without the power to spin them. For an idea of just how much power is needed, look no further than one of Bugatti's biggest competitors in the race to 300 miles per hour, Hennessy. The company's upcoming Venom F5, estimated to reach 301 miles per hour, houses a 6.6-liter V8 that makes an astounding 1,817 horsepower. To generate more horsepower, an engine has to burn more gasoline, which requires more air. One of the most common ways to feed more air into the engine is through turbochargers. The Venom F5 not only uses massive twin turbochargers, but it also manages to reach a very high RPM. RPM stands for revolutions per minute, and it measures how fast the engine is spinning. In general, the faster an engine spins, the faster it burns air and gas, and as a result, the more power it makes. A smaller engine with smaller and lighter parts can spin faster with more efficiency, but has potential to wear out quicker from the speed than a bigger engine with a lower RPM. All of this has to be taken into consideration when choosing an engine for speed records. But in the end, the biggest obstacle to 300 miles per hour is air. The drag, or air resistance, that a car encounters as it approaches this speed can be compared to what you encounter when swimming.
The resistance increases in square. So going from 200 to 300 is basically, roughly calculated, double the energy that you're running into. At around 200 miles per hour, you get more into aeroplane aerodynamics, where you're actually compressing the air in front of the vehicle, and it takes different routes over the bodywork than at slower speeds.
That's why the goal of engineers when designing a hypercar's body is to eliminate as much drag as possible. No car does this better than automaker Koenigsegg's upcoming Jesko Absolute. Based on the company's Jesko hypercar, the Absolute is estimated to reach as much as 330 miles per hour. Similar to Bugatti's record-breaking Chiron, it has a longer flattened tail. This makes sure air flows off the car's rear seamlessly. Without it, you have a higher chance of separation in the airflow, which would only add to the drag. The car also improves other forms of resistance. The standard Jesko features a massive rear wing to increase downforce for those tight corners on the track. But downforce on the rear wing of a 300 mile/hour car would only slow things down. Ditching the tail reduced the Jesko Absolute's maximum downforce from over 3,000 pounds to just 330. To keep the Jesko Absolute from flying off the sides of the test strip, that massive rear wing was replaced by two small tail fins. They may look tiny, but they redirect the vortex of air generated behind a speeding car that creates turbulence. And those sharply cut side vents do more than just cool the engine.
They act like kind of small side parachutes. They actually become kind of fully efficient over 200 miles per hour. And the reason for that, if they work better at lower speed, they would be too restrictive at higher speed. They would be blocking too much.
But as impressive as these automakers' innovations have been, none of it would be possible without the way testing has advanced. An aerodynamic simulation that took a week to run 10 years ago can now be done in 3 or 4 hours, allowing new solutions to be tested immediately. And while Bugatti may have already been the first to reach 300 miles per hour, automakers are constantly chasing the next record.